Factorising the following expressions where the coefficient of a is greater than 1. In order to factorise expressions where the coefficient, or the first number in the quadratic, is larger than 1, we need to use what we call the squiggly line method, or splitting the middle term. Okay, so the method in which we do this is we need to first off multiply a and c, coefficient of a and coefficient of c together, and determine the coefficient of b. So just to recap, the number in front of the x squared term is a, the number in front of the x term is b, and then the number at the end is c. So first we need to multiply a and c, which in this case is 3 times 8, which gives us 24. And the b coefficient in this case is 25. So the very first thing you need to do is you need to find a pair of numbers, or a number pair, that when you multiply, they multiply to 24, and when you add them together, they add to 25. Okay, so the product of the two numbers multiply to 24, and the sum of the two numbers add to 13. So in this first example here, pairs of numbers that multiply to 24 could be 1 and 24. You could also have 2 and 12. And you could also have another one could be 6 and 4, for instance. Okay, and numbers that add together to give you 25 is 24 plus 1. Okay, and you can see straight away here that two numbers that multiply to equal 24 and add to 25 would be 24 and 1. So that would be your number pair that meet those two different constraints. So once you have your number pair, you need to split the middle term, okay, by using those two number pairs. So instead of having 25x, you're now going to have 24x and x. Okay, so copy this over. All right, you're now going to have 24x and x. All right, you haven't changed your expression, okay, because 24x plus x still equals 25. You've just split them into the number pair in order to factorise it out further. Okay, so once you have it at this stage, you then factorise, you split it using a squiggly line. Okay, I'm just going to do a gap here because I'm on the computer. And you're going to factorise the first half, and then you're going to factorise out the second half, finding common factors. Okay, so 3 is a factor of 24. 8 3s are 24, so I can take 3 out because it's a factor of both those terms, and I can also take out an x, all right, because x exists in both of those terms. That would leave me with an x left over because x times x is x squared, plus 8, because 8 times 3 is 24. We then know that the other half has to also factorise out to give us an x plus 8. Okay, and you can see that it already is x plus 8, so there's nothing that we can change about that. So therefore, the only common factor that you could take out is a common factor of 1 in this case. All right, and then what you do is you group them together. So x plus 8 would be your first bracket of numbers, and then your second bracket of numbers are the factors on the outside. Okay, so you take the bracketed number combination out first, and then what's left over in this case, it's 3x plus 1. So you'd go 3x plus 1 would be the other factorised bracket. Okay, so you've now factorised out a quadratic where the coefficient is larger than 1.